Hello class. This video in particular I think is going to be very interesting to a lot of you. It's going to kind of put a little bit of meat behind why we have been learning what we have been learning for the past 3-4 days, I suppose. So I've kind of been touching on how important this is to learn because it's used in everyday life quite often, and here we just have a couple examples of that. So what we're doing today is we're modeling real world data. We're going to be using scatter plots, so this kind of goes into a little bit of statistics, which you're going to get to more later on in this trimester, but we're going to touch on that today. So what we're going to be doing is we will be using data to make predictions about the lines of best fit. We will do this by hand and also with using our graphing calculator. So make sure you have your graphing calculator for this lesson. You're gonna need it. You won't be able to do these problems without your graphing calculator. Likewise on the test, make sure you have those graphing calculators because there are some problems on the test that you just can't do if you don't have a graphing calculator. So get those out. First one. This one, the table shows the average fuel efficiency in miles per gallon of new cars manufactured during the years listed. So in 1960, the average car got 15.5 miles to the gallon. And then as hopefully, if you have a working knowledge of the progression of technology and stuff like that, you understand that as time goes on, as technology gets better, things just become more efficient. Computers have become more efficient. Vehicles have become more efficient. Sports equipment has become more efficient. Musical instruments have become more efficient. As technology increases, we're able to be more efficient. So, kind of strange actually, in 1970, the average car only got 14.1. So in that decade, it actually went down. But then as you could see in 1980 and in 1990, they went back up again to 22.6 miles to the gallon and 26.9 miles to the gallon. So as you can see, we're increasing. So now this is beneficial because we can kind of make predictions. What do you think it's going to be in the year 2013? What do you think it's going to be in the year 2020? When you guys are grandparents and you buy a car in the year 2080, something like that. When you buy that car in 2080, what would you predict the miles per gallon to be? This is the lesson that will teach you how to do that. So the first thing you have to do is you have to come up with an equation of a line. And now we pick the line of best fit. We can't draw a straight line that goes through all 4 of those dots. It's just impossible. So what we're going to do is we're going to draw a line of best fit. And what a line of best fit is it's just a straight line that best represents all 4 of those points. So it's going to be a straight line. Let's try to get a straight line that goes through the average, I guess, of those 4 points. And class, it has to go through 2 of them. So pick 2 points that this line is going to go through. And if you see what I'm seeing, I would say that it goes through those 2 points. You have 1 point below your line, you have 1 point above your line, so hopefully you can see that this line that I just drew up there best represents my data. So make sure that you go through those 2 lines as well so that we can have some consistency. Alright, so now with these, you only need 2 points to name a line. That's all you need. And so as you can see, we do indeed have 2 points. Once we have these 2 points, we're going to get into y equals mx plus b form using the strategies that we've learned the last 3 days. So my 2 points, this one is the point 1960, 15.5. The x-axis is 1960, the y-axis is 15.5. My next point right here is at 1980 and at 22.6. Obviously, I got the 22.6 right over here. So my second point is 1980 for the x-coordinate and 22.6 for the y-coordinate. All right, once you have these 2 points, you want to get the equation of this line in y equals mx plus b form. So the first thing you have to do is you have to find the slope, because the slope is going to help you put it into point slope form. So my slope, m, equals y2 minus y1 over x2 minus x1. So let's just call one of these x1, y1. Let's call the other one x2, y2. Subtract the y's. 22.6 minus 15.5. Put that in the numerator. Subtract the x's in the denominator. 1980. 1980. Subtract 1960. When you subtract these two, the numerator and the denominator, that is, you get 7.1 over 20. 7.1 over 20. Now, class, usually we have our slope in a fraction. On these type problems, it's more efficient to have your slope in a decimal. So what I want you to do on this one is I want you to divide 7.1 by 20, 7.1 divided by 20, and round to 3 decimal points, which is m equals 0.355. 0.355 is the slope on this problem. All right, once you have the slope, what we want is we want the equation of a line. So the first thing we have to do is we have to put it into point slope form. Y. Let's use a different color. We're starting a whole new train of thought. Y minus y1, that equals m times the quantity x minus x1. It doesn't matter which point you use as far as the y1 and x1 goes. You can use either of these two. I generally like to take the one that has smaller numbers, because usually the smaller the number, the easier it is to do mathematical operations with it. So I'm going to use this point, 1960 and 15.5. So y minus the y coordinate, which was 15.5, that equals our slope, which is 0.355, times the quantity x minus the x coordinate, which was the year 1960. All right, on all these real world type problems, I want your answers to be in y equals mx plus b form, that slope intercept form. That's the one that is probably the most beneficial to us. So let's distribute that 0.355. Y minus 15.5, that equals 0.355x minus 1960 times 0.355. That number is, looking at my notes, 695.8. 695.8. Okay, and now to get y all by itself, we have to add this 15.5. Add this 15.5. And so the equation of the line of best fit that we drew back up top is y equals 0.355x minus, when we subtract, what am I subtracting? 695.8 minus, or adding 15.5, we get a negative 680.3 minus 680.3. So this is the answer of that line that we wanted for our line of best fit from back up top. Now you might say, Mr. Berge, how in the world is this beneficial to us? How is this real life information? And the answer to that question is, you guys are now in the year 2013. If it's 2013, when you buy a vehicle and it's average, what is the miles per gallon that you should get? The higher the miles per gallon, obviously the less money that you spend. Especially if you have a job and you have to commute to work and it's a long ways away, you're going to want to get a vehicle that is very fuel efficient. So this is something that would directly affect your life. So in the year 2013, I ask you, class, the year 2013, and am I going to put that in for the x-axis or the y-axis? If you look at this, all of the years were in the x-axis, correct? So if we substitute in 2013, we're going to substitute that in for the x coordinate. So this is in 2013, average vehicle should be Let's find out. Y equals 0.355, 0.355 x, which x is now multiplied by x, which x is now 2013. And then I'm going to subtract that 680.3. All right, class, and now you can just do the rest of the work in your calculator. Order of operations says you multiply first, and then you subtract second. So in your calculator, multiply 0.355 times 2013, subtract 680.3. What should your vehicle be getting in miles per gallon if you buy a 2013 vehicle? And the answer is Y equals 34.315 miles, 315 miles per gallon. If technology increases at the same rate as it did in 1960, 1970, 1980, 1990, so on and so forth, when you drive, you should be able to drive 34 miles on 1 gallon of gas. So if you have a 10-gallon tank, you should be able to go 343 miles before you have to fill up. So is this the case? Is your vehicle more than average? Is it less than average? This is something that you can analyze on your own when you get out into the real world. I had one more thought with that. Another way that you could go about using this information is if you want to say, what year should a new car get, let's say, 50 miles per gallon? That's a very good question. When am I going to get a car where the average is 50 miles per gallon? Right now, it's far from it, as you guys well know. If I wanted 50 miles per gallon, isn't that my y coordinate? These are all miles per gallon. 15.5, 14.1, 22.6. So into this equation right here, instead of substituting in for the x, I would substitute 50 into the y. And then I would then obviously solve for x. So very beneficial problems. I'm also going to teach you how to do that using your graphing calculator. However, I'm going to teach you on number 2 instead of doing it on number 1. So let's try this exact same thing now on problem number 2. We see our coordinate, or we see our table. Why don't we put all of those on our graph off to the right? So we have 1, 1. Put that on your graph. 3, 5. Next one is 4, 7. 6, 11. 7, 12, 8, 15. 7, 12, 8, 15. All right, class, what I'm seeing is a pretty straight line. I mean, it doesn't look like there's too many deviations above or below the line. What you're going to do is you're just going to draw a line of best fit. And this is where it gets a little bit tricky because each person's line of best fit might be a little bit different. Hopefully they're all very relatively the same, but they very well could be different. What I'm going to do here is I'm just going to draw a straight line. Oh, it looks like it's going to be maybe right about there. And like I said, everybody's line is going to be different. I just want to make sure that I'm clear on one thing. You have to go through 2 points. When you make your line of best fit, a straight line has to go through 2 points. So make sure that that happens. And now, class, we want our equation of this line. Kind of like I said in that last video, what is this line's name in y equals mx plus b form? Well, you have to find the slope and then use the slope and then use that slope to put into point slope form and then change it into slope intercept. So I have to pick 2 points that this graph goes through. And it looks like it goes through 1, 2, 3. It kind of looks like I could pick any 4 of those points. So on a test class, if you pick this one and this one, you would do the right thing and you would get the right answer. If you chose this one and this one, you would also get the right answer. Even though they might not be identical to your neighbors, that's just fine as long as you do your work right. So I want to be very, very clear on that. You can pick any 4 of those points. Generally, I like to pick the smallest ones because, once again, they're the easiest to do basic mathematical operations with. Multiply, divide, add, subtract. So I'm going to pick those 2 points. Those points are my first 2, which is 1, 1, and 3, 5. So I'm going to do that whole process that I've been doing the past week, basically. It's going to be finding my slope, which is y2 minus y1 over x2 minus x1. 5 minus 1 divided by 3 minus 1. We'd get 4 halves, so my slope is 2 for my line of best fit. If my slope is 2, y minus y1 equals m times the quantity x minus x1. And I could pick either one of these 2 points, like I said on last problem. I'm going to pick this one just because the numbers are smaller. So we have y minus my y coordinate, which was 1. That equals my slope, which is 2 times the quantity, x minus my x coordinate, which was also 1. So as I continue working to put into y equals mx plus b form, y minus 1 equals 2x minus 2. So my equation, y equals 2x. If I add 1 to both sides, I would get minus 1. Y equals 2x minus 1. So this is the equation of the line of best fit, which we had up top. Y equals 2x minus 1. Now, class, as you can see, there is a highlighted question mark here. I am saying when x is 10, what do you think my y is going to be? So here would be 9. 10 would be just off my smartboard, I suppose, so 10 is way up here. And if this line were to continue at the rate that it's going at, what y value do you think it's going to be at over here? We can do that simply by substituting. If I want to know what my y is when x is 10, I'm going to substitute 10 in for my x coordinate. I'm going to substitute 10 in for my x coordinate, and then we're going to find out what y is. So y equals 2 times x, which I said x was 10. 2 times 10 minus 1. 2 times 10 is 20, and 20 minus 1 is 19. So my answer is y equals 19. And I want to see all of this work just as I'm doing it here on the smartboard. This is how I want you to do it on your test. Now, do you want to know the easy way to do it? I'm sure you would say, yes, Mr. Berge, show me the easy way. We can use this wonderful thing that man has made in the graphing calculator. So pull out your graphing calculator. I will open mine up. Okay, so we have this. What we're first going to do is we have to enter in all of our information. So what we're going to do is we're going to start off by doing this. You're going to press this stat button, which is the third column, second row, stat. And then you see 3 columns up top. It says edit, calc, and tests. You're going to press the edit one. So right here, you're going to press enter. And now as you can see, you should have 3 columns. It should say L1, L2, L3 up at the top. If yours does not say L1, L2, L3 up top, make sure that you bring that to me in class tomorrow because I need to reprogram your calculator to have that. So make sure that you bring that to me if you don't have L1, L2, L3. Some people, they accidentally delete a column, so then it says like L2, L3, L4 or something like that. Make sure L1 is always that first one. So what I did on my calculator, and let's just be consistent. You don't have to do this, but I would encourage you to do it just for consistency's sake. Why don't you guys practice entering in problem number 1? That was the miles per gallon. So if I were to do that, as you can see, I have a blank list now, as I'm sure you guys have it on yours. So all you do is you just put your cursor, I could go up and down in all sorts of different directions, put your cursor under that dotted line and enter in the information by pressing 1960 and then enter. 1970, enter. 1980, enter. 1990, enter. And now go under list 2, that's what L2 stands for, and enter in those 4 pieces of information: 15.5, 14.1, 22.6, 26.9. If you guys don't know, if you have information in there that isn't the right information and you don't know how to clear it, all you have to do is highlight the whole list, highlight L2, and what you're going to do here is you're going to press the clear button. Very important, do not press the delete button. Okay, if you press delete, it will delete the whole column, and then that's bad news. Only press the clear button, that clears the information. So if I press clear and then down, as you can see, all of my information is gone. So I'm going to re-enter that with you. 15.5 is the first one, and then 14.1, enter. 22.6, and then last one, 26.9. All right, so what I want you guys to do, pause the video, do the same thing for L3 and L4, this time using problem number 2, which is the problem that we're doing right now. 1, 1, 3, 5, 4, 7, 6, 11, 7, 12, 8, 15. Enter in that information. All right, once you've entered in that information, what you want is you want the line of best fit. So here's how you go about doing that. You're going to press that exact same stat button that you started off with, which is the 3rd column, 2nd row. Stat. This time, instead of edit, you're going to go over a column and highlight the calc button. So all I did was push the right arrow so I can go right 1 column to get to the calc. And what you want to calculate is number 4, a linear regression line in AX plus B. That's where a line of best fit, another name for that is a linear regression line, and you're going to press enter. Now class, this is very important. Your calculator needs to know which lists, to program this linear regression line. So do they want list 1, list 2? Do they want list 3, list 4? Do they want list 9, list 10? What lists do you want the calculator to program? And in this one, we put L3 and L4 in for our information, list 3 and list 4. So you're going to press the 2nd button and then press 3. As you can see, the L3 shows up, and if you guys can see this on your calculator, when you press the number 3, right above it is that L3 in blue. So obviously that's what that means. So linear regression line in AX plus B, 2nd L3, and then you're going to press the comma, which is right above the 7. And you also want list 4, so 2nd L4 or 2nd 4. So you have that, 2nd L3, comma, 2nd 4, and then you're going to press enter. And as you can see, in Y equals AX plus B, A equals 1.937, and B equals a negative 0.866. If we were to round to 3 decimal points, I guess A would be 1.938, and B would be a negative 0.866. Let's write that down. So this is using our graphing calculator. Using our graphing calculator, we got our A value to be 1.938, 1.938, and we got our B value to be a negative 0.866. All right, class, now it said this was in the form of y equals ax plus b. Now hopefully this sounds a little bit familiar to you. We're used to seeing y equals mx plus b, where m is the slope. For some reason or another, our calculator says that a is the slope. Instead of mx plus b, ax plus b is the slope. So the slope of our calculator is going to be 1.938. Now class, you might say, how come we got a slope of 2 where our calculator got a slope of 1.938? Very, very close. Humans are not perfect. We err. Okay? That's just part of our nature. We're going to do things wrong. So we can't be absolutely perfect. However, the calculator is absolutely perfect. It takes a complete average of all of these points up top here, and it makes a perfectly straight line that best represents all of those points. So your calculator, perfect. You are imperfect. It's just the way it is. And then it says that our y-intercept is at a negative 0.866. So our equation, y equals 1.938x minus 0.866. It's the same y equals mx plus b form. Instead, it's just ax plus b. So this is the equation using your graphing calculator. And then we want to again substitute in 10 in for the x-coordinate, because we want to see what will happen for y when we substitute in 10. We want to make a prediction. So y equals 1.938 multiplied by 10, and then subtract 0.866. And after doing all that work, first multiply 1.938 times 10. Secondly, subtract the 0.866. You get an answer of 18.514. 18.514. Now class, once again, this is the exact answer. When we predicted, we got y equals 19. So hopefully that will always be the case. Our answers will be close. They won't be perfect. However, they will be close. All right, last one for the day. I want you guys to pause the video, and I want you guys to do this problem all on your own. And now, again, remember, we might have slightly different answers if we pick two different points than each other. So keep that in mind. Pause the video, try it on your own. As I did problem number 3, the 2 points that I went through were 5, 9, and the other point was 25, 30. Now class, if you didn't use those 2 points, you could still get full credit on the test. I want to be very clear about that. You don't have to pick the same 2 points that I chose. Just make sure, I'm going to make sure that whatever 2 points that you did choose, that you did the rest of the work right. So if you chose those 2 points in slope-intercept form, you should have gotten this for the answer. Y equals 1.05x, 1.05x plus 3.75. So then, doing that, we want to make the prediction for 50 in our x-coordinate. So y equals 1.05 times the x-coordinate of 50, then add 3.75. So our prediction when x is 50, y is going to be 56.25. Y equals 56.25. All right. You may not have gotten exactly that, but hopefully it was close. Now, when I do the work on the calculator, you should get exactly what I get. It's very important that you're careful when entering the data into your calculator, because one little slip of your index finger while entering the information can really be vital to skewing our information. So make sure that you're very careful when you enter in the data. I want to also point out something. When you enter in the information, you're not going to put 50 into your calculator. As you can see what I did here for list 5, list 6, hopefully you did the exact same thing. Stat, edit, list 5 and list 6. There they are. I stopped at 40, 44 for that last point. 40 and 44. Which, as you can see, 40 and 44 is right here. If you can't enter in a y value, you can't enter in an x value. So don't even enter this in your calculator when you're doing the information. So 40, 44 is your last one. And then what you're going to do is you're going to find the a and the b value that the calculator gives you. So you're going to go to stat, over one column to calculate. Go down to number 4, which is a linear regression line, and ax plus b. Enter. This time you want list 5 and list 6. So second 5, which is L5, comma, which is right above the 7, second L6. Enter, and there you are. Your a value is at a 0.955, and your b value is at 5.187. So for the work on your calculator, your a value was 0.955, and your b value is 5.187. So y equals mx plus b, or y equals ax plus b, 0.955x plus 5.187. And now we're going to make that prediction when x is 50. So that 50, substitute in for the x. Y equals 0.955 multiplied by 50. Then add 5.187. So after multiplying and then adding, you should have got a value of y equals 52.937. 937. And as you can see, the calculator being perfect is not exactly like our answer, which is imperfect. But this is how I want you guys to do it for your assignment, and this is how I want you to do it for your test. So, here is your assignment. Your assignment is worksheet 2.5. When you're doing your worksheet, I want you to do problem number 1 by hand and by using the graphing calculator. So I'm gonna look for work on both by hand and by using the graphing calculator. For number 2, I also want you to use the calculator as well as do it by hand. However, as you can see, there's no variable on this one, so you don't have to make any prediction at all. That's number 2. Number 3, you only need to do this one using your graphing calculator. You don't have to do it by hand. And for number 4, same thing. You don't have to do it by hand, only use the graphing calculator. So numbers 1 and number 2, do it by hand and by using the graphing calculator. Number 3 and number 4, only use your graphing calculator. Best of luck to you with this assignment. Let me know if you have any questions.